Look at this drawing of two vertical lines with arrows on the ends. Which appears longer? Even if you grab a ruler and prove they are identical, your brain refuses to see them as equal. The visual impression overrides your conscious logic. If conscious logic cannot correct a simple optical illusion, it raises an uncomfortable question. What other biological processes are secretly lying to you right now? Human decision-making is driven by a highly specific, deeply flawed cognitive architecture, a biological machine that shapes our choices long before our rational minds even wake up. For decades, social science relied on the myth of Homo economicus. This model assumed humans were logical actors, and any bad choice was just a random burst of emotional noise interfering with our perfect rationality. Daniel Kahneman tore that model apart. Synthesizing decades of research, he demonstrated that human errors aren't random noise. They are predictable, systematic mistakes built into the design of our cognition. To escape these invisible biases, we have to map the exact mechanics of this mental machine and understand where it fails. Think about navigating a chaotic city street during rush hour. You brake, swerve, and track pedestrians perfectly without consciously calculating any of it. That effortless calculation is what Kahneman calls System 1. It operates automatically, continuously processing immediate threats and reading facial expressions in milliseconds. Compare that fluid autopilot to the sudden, jarring mental roadblock of solving 17 multiplied by 24. That requires stopping, retrieving a mathematical rule, and spending focused attention. Because System 1 works so fast and without our consent, the immediate feelings it generates are just rough drafts from an autonomous machine, not absolute truths. When you finally pause to solve that math problem, you engage System 2, the deliberate logic center. But this conscious reasoning operates on a strictly limited biological budget. Early physiological research on pupillometry inspired Kahneman to measure the exact biological toll of that intense mental work. This animated diagram tracks the results of a high-focus exercise called the Add-3 task. As mental load hits its peak, the pupil physically dilates by 50% of its original area, and the heart rate spikes by 7 beats per minute. This intense exertion demands so much capacity that it temporarily disables your orienting functions, causing phenomena like missing a person in a gorilla suit walking straight through your vision. Because this energy cost is so high, System 2 acts as a lazy controller. If you make high-stakes decisions while mentally fatigued, this exhausted system will simply endorse unverified impulses to save energy. When faced with a complex problem, the brain often relies on a heuristic, a cognitive shortcut that quietly replaces a difficult statistical question with a comfortable causal one. Kahneman and his collaborator Amos Tversky validated this dual-system psychodrama when they noticed their own elite mathematical intuitions were failing them during research. To test this, they surveyed textbook authors at the Society of Mathematical Psychology. They found that even statistical experts consistently fell for the law of small numbers, mistakenly predicting reliable results from tiny samples. Acquiring a precise diagnostic vocabulary, like labeling a poor hiring choice as the halo effect, is the required mechanism to force System 2 to wake up and audit these natural shortcuts. This architecture also distorts our perception of the past. There is a biological divide between the experiencing self, who lives in the present moment, and the remembering self, who keeps the final score. Look at this timeline chart tracking a 2-week event. According to the peak-end rule, human memory completely discards the actual duration of the event, focusing almost exclusively on the highest peak of intensity and the final moments. If you suffer through a single miserable hour at the end of a long, pleasant vacation, the chart drops the baseline data entirely. The remembering self permanently overwrites the history of the trip based on that final score. Because endings are the only data the cognitive machine reliably retains, you have to strategically design the final moments of your professional and personal experiences. Studying these cognitive errors is a medical diagnostic tool, not a pessimistic critique of human intelligence. Identifying where we fail is how we learn to improve. For example, encountering a patient with psychopathic charm is a specific clinical danger sign. It signals that your System 1 urge to trust must be manually overridden by deliberate logic. Formalizing this behavioral economic framework provided a precise map of human decision-making, a map that ultimately earned Kahneman the Nobel Prize. Continuous vigilance against your own mind is biologically impossible. The only defense is to learn your specific danger signs and selectively spend your conscious energy right when the stakes are highest. In an environment where most actors blindly trust their intuition, the ability to recognize the design flaws in your own logic provides a concrete tool for more reliable decision-making. Thank you for exploring the architecture of cognition with us. We'll see you in the next one.